Okay, so I'm going to talk this morning about various things, about NR56, but I'm going to start by talking about standard designs and the approach to design of S&C. So yeah, I'm going to start with the principles of S&C design, but thinking about this at an assembly level. And then, like I say, I'm going to go into more detail about NR56 in terms of layouts, switches, and then talk about further developments or future developments for NR56V. So there we are. A lot of people I talk to say they're involved in S&C design, but when I actually get talking to them, they all do slightly different things. And one person's S&C design is different from another person's. So we know which level, I always say this to people, which level of S&C design are you into? People who are involved in scheme design are more familiar with the picture on the left there. It's how the overall scheme's going to go, what units of S&C we're going to put in there, how the geometry works. Then you get people who go into more the layout side and the sub-assemblies that make out the layouts, the switches and the crossings. And then other companies, other people are very specialised, they look at the component level. So the picture there on the top right is very much saying, you know, that the stretchy bars, the lock stretcher, the roller base plates and things like that. So they're all S&C design issues, all very different, and different skills are actually involved to produce those and to do that design work. So again, just thinking of things at a high level, the things we've been doing in Network Rail recently, thinking about design at a turnout level. So before we start that, we need to define what we're actually going to be doing and what considerations we need to make. So we need to define the range. So we need to define the range, the sizes, whether we're talking about turnouts and crossovers and double junctions, whether we're going to include complex S&C. We need to think about standardisation. It's a word I'm going to use a lot this morning. But we need to think about which aspects we want to standardise. We need to think about what the main reasons for carrying out the design are. Is it speed? Is it performance? Is it cost? The footprint, the compatibility with existing S&C systems, is that an important issue? We know now that if we start to change the footprint, we get significant costs with moving overhead line equipment and signalling equipment. But then we're constrained by sticking to the same footprint. Modular transportation has been something that's been relatively new to us in the last few years, and that in itself needs to be considered at the design stage. So overall requirements, now there's a vast list here, but I've already mentioned speed, axle loading. We're pushed nowadays to have low maintenance S&C. But it needs to be cheap, it needs to be reliable. So sometimes we say to people, which do you want? The answer normally comes back and saying we actually want all of them, and more besides. What type of technology are we going to apply? So things like, probably more applicable to switches, but are we talking about shallow depth? Are we looking at fully well-leveled turnouts? Are we looking to stress it? Are we going to use direct fixed bearers or base-plated bearers? Things like metric bolts, what type of clip, what type of pad. They're all things that we need to agree early on in the day. Talked about issues from past experience. Normally when we set off on a design project, we've got lessons from the past. Normally lessons that we've learned through mistakes, from problems that we have in the past. So we normally get a list of things to say, when we redesign this, we must sort out these issues, we must resolve these issues. Some of the other things we need to consider is not just the bearers, but what's underneath the bearers, what I often refer to as the suspension system, and that's something that we're starting to look at in more detail now, because the performance of the S&C is very much down to what's happening underneath and how it's supported. So thinking again about the principles, about switch design, we need to think about the switch geometry. So this is really taking the whole layout and now just focusing on one area. So within the switch geometry, we're talking about things like the radii, the switch radius, the planing radius, but also the actual way we make the transition at the toe, be it secant, tangential or clothoidal geometry. This is really the way for those who don't understand this, it's the way that the curve translates into a straight line. We can't have a perfect curve carrying on forever, otherwise the switch would end up many metres longer than they are in reality. We need to talk about and think about the blocks, the materials that the blocks are made out of, the spacing, the heel. It's always a controversial area. Do we use a ball and claw or do we use stress transfer blocks? Think about the way those are tolerant, the way they're designed to fit, the design intent, and also the fixings that we're going to use. Within the switch, just like within the rest of the layout, it's which clips are we going to use, what toe load do we need to apply. Then we get to the POE, points operating equipment, the supplementary drive as well as the primary drive, all the compatibility issues. We need to think of S&C as a system. Oh, and don't forget the points heating. There's a point there that on a recent project I'm going to be talking about in a bit. If you forget the points heating, it can land you in hot water. I don't know if there's anyone from the Western route here today, but they know exactly what I'm talking about there. The other thing, of course, are profiles within switches. Within a switch, we're aiming to get an efficient and safe wheel transfer between one rail and another. And what we do with the profiles can obviously guarantee that, but it's not just what happens when they're new, it's what happens when they're worn, and how we're going to inspect that and how we're going to maintain that. So thinking about crossing panels then. Nice complicated example of a crossing panel there in the picture. That's one of the Reading layouts. But what type of crossing? Well, what do I mean by type of crossing? Firstly, it's whether it's a common, obtuse, or in the picture there, a compound crossing. But the other type of crossing is what type of construction. So are we talking about cast? Are we talking about fully fabricated or semi-fabricated crossings? So again, a good lesson from the past about footprint, particularly with cast crossings. Do we need to define the footprint, or do we let the crossing manufacturers define the footprint? These are the kind of things that need to be considered. I'll talk a bit about crossing footprint in more detail in a moment. Again, I've talked about pads. Pads are particularly important in the crossing because the impact forces at a wheel transfer within the crossing are about 2.5 times the normal rolling loads. So it's not just designing the pads for normal rolling load, it's designing them to withstand this high impact force in this area. And not forgetting, of course, I'm talking here not just about the crossing but the crossing panel. This includes the check rails, and the way that the crossings and the check rails interact is very important. Things like the check rail gauge and the flangeway of the check rail. The way we measure check rail gauge, the dimensions and the tolerances, and again the maintenance limits that we apply. And then within the check rail, what type of check rail? Are we going for an adjustable check rail or a fixed check rail? So when we sit down to design a new style of S&C, these are the kind of things that we have to consider, and we try and do as much of this before we start and get specification, and then we get into the detail beyond that. So now I've set the scene a little bit, I want to talk about NR56V. So when you look at those two pictures, apart from the fact that one's got a clamp lock, an in-bearer clamp lock, and one's got a HW point machine, you could actually say, what's all the fuss about NR56V? It looks very similar to the other layout that's shown in the picture. So one of them's NR56V, one is an older style layout, £113 UIC 54, whatever you want to call it. So why are we doing NR56V? I was just going to say about that. So let's go to NR56, let's just talk what NR56V is. I'd say this is the new name for shallow depth vertical S&C. And I'm going to explain now what's different and what's the same. But it's something that we're going to be rolling out in the very near future. So anyway, why NR56V? Well, there's two main reasons, I think. One was about standardisation. It's standardising bearer spacing, it's standardising the design detail of the concrete bearers and getting that design information onto a standard network rail drawing. It's standardising crossing footprints, and it's standardising joint positions and panel sizes that enables us to use the modular transportation and installation methods. The other thing about are improvements. Plain line track, there were massive improvements made in, I think it was the 80s and 90s really, before I got involved. So using higher toe load clips, using more resilient pads, these things that we've really, S&C was left behind. So we're using NR56V as the opportunity to bring S&C up to date, more in line with the techniques that are used on plain line. The other thing is metric bolted fastenings. A lot we've perpetuated for many years with metric fastenings, metric bolts on the railway. This time is the time to move to metric fastenings here. But we're not just moving to metric fastenings, we're using locking nuts as well. So we've got basically a higher integrity fastening, one that doesn't rely on a patroller going around with a spanner, checking everything's tight. Okay, so a little bit about the range. NR56V. It's been designed originally for turnouts and crossovers with switch sizes AVS through to FVS. The reason for this was in our policy we envisaged the longer switches would be NR60. So the plan is, in fact we've got them all virtually complete now, to produce REPW drawings for all the preferred geometries that are in the design handbook. But we have realised, and various bits of feedback that we've had from the projects, is that they would actually like a design for the SGVS and the GVS switches as well. So we've actually now commissioned that work. As well as turnouts and crossovers, we've also got a range of double junctions, and I've just put the details down there for interest. 4 sizes of double junction that are going to be included in the range. So again, those drawings are virtually, well, the primary version's actually available now. We've had some feedback following some of the early pilot installations of plain leads and crossovers, and they're being updated at the moment, but they'll be available in the very near future. So the basic design principles of NR56V. I've talked about standardisation and switch and crossing footprints. We've kept the same switch footprint as the existing shallow depth vertical. So an NR56V half set of switches can be interchanged with an old style shallow depth half set of switches. We've standardised on the crossing footprint. As I say, through history we've ended up with a range of different footprints. And this really has given lots of problems in maintenance. We get occasional tales of woe where someone's ordered a crossing, they've got into their possession on Saturday night and it won't fit. Very, very few and far between, but it does happen. So we've taken the opportunity here to standardise on one. Rather controversially in some people's eyes, we've chosen the Edgar Allan cast centre block. We had some good reasons for doing that. We had to choose something, and basically each crossing manufacturer now has had to develop a range of crossings that suit that footprint going forwards. The geometry of the layouts is exactly the same as the existing shallow depth vertical. So for people who are involved at a scheme level, it's exactly the same. The only thing that does change is the position of the last through bearer and the long bearers. So, but the overall geometry remains exactly the same. And as a consequence, we keep the same layout footprint. So if you're doing a like-for-like renewal, you can put a new NR56V layout in its place and you aren't having to move the equipment. So I talk about some of these terms. I don't know if people know what I'm talking about, so I've tried to include a few slides here just to explain a little bit about what it's about. So when we talk about the switch footprint, well, what does that actually mean? When we're doing a layout on concrete bearers, if the holes in the bearers aren't the same, then we can't change a half set, and we end up with different variants. And again, if we're not careful, if we create a new switch for NR56V, we end up with the same situation that we have with crossings. So it's holes in the bearers, but it's not just holes in bearers, it's also looking at where we go from base plates, because the slides are base plates obviously. There's normally then a heel base plate. I should just use a pointer. So here, if you see, we've got, this is a heel base plate, and this bearer here is the first direct fixed bearer, so there's no base plate in this location. So these are really our constraints for switches and for the footprint. So if we could change things in this area, but like I say, we wouldn't have compatibility with the existing designs. So then we'd be saying, do you want a half set of switches to the old design or to NR56V? And it's the same with crossing footprint. Like I say, this shows an example of the cast centre block design that we've standardised on. We started off talking about footprint as literally what it is. It's the physical, if you took a crossing and drew round it, it's the kind of imprint that you would have. But there's more to, talk about lessons learned, there's more to footprints than just the shape of the base of the crossing. Other things that have to be taken into account are the clipping arrangement, particularly in the middle of the V. There are different ways of doing this, and in the past some people have put blocks in, some people have used these clamps. If you end up with one crossing from one manufacturer with blocks and the other one that relies on clamps, again, you lose this interchangeability in maintenance. So it's important when we specify the footprint, we specify the holding down method and whether we're using blocks. Additionally, as you can see, this is a welded crossing, you've got the tri-metal welds here. Then it's important that we have some control over where they are, because again, if you're not careful, if one manufacturer's casting is longer and you end up with the weld in a different bed, then the site welds can end up in a different position and you can end up with a substandard leg length. So this isn't as clear as I would like it to be, but it just gives an idea. This is what we've now specified on an REPW drawing. So we've specified the pad sizes where the crossing sits. We've specified the weld positions, the overall leg lengths, and we've specified the block arrangements or the clipping arrangements. There is a note on here because we've had queries from different cast crossing manufacturers and said, but our crossing needs to be a bed longer. And what we've said is we can agree that through product acceptance as long as the leg ends remain in the same position and we're not compromising the minimum distance between welds. So as far as the project's concerned, the overall length of the crossing will be fine and we don't have any substandard leg lengths. The flash foot weld could be in a slightly different bed, but if we're compromising that, then obviously we have to insist that the welds are in a particular position. Talked already about modular panels, and again, I don't know how familiar people are with these. These are the splice joints that we now get. So these joints positions are all shown on the REPW drawings. You don't have to have the joints if you don't need them, so it's still possible to make a layout with bearers of full length, but if you need to adopt this type of technology, we've specified where the joints have to go. And again, we end up with this standardisation. Just for information, this is the bit that you don't normally see. So underneath here, this is a shear plate that's applied to the end of the bearer. And this does a number of things, but basically it ensures that we've got good strength around these holes on there. So that's something we don't often see unless you're involved with the actual construction. So I said already previously, a lot of the design detail of the concrete bearers had been, I say lost, it wasn't within Network Rail control. So as part of the REPW drawings now, within the CAD version, you can click on and you can actually pick up the housing positions from that CAD drawing. So again, we've got control of that data. So going through on the through route, the housings are here and they're all quite straightforward. When you start to go round onto the curve route, on a turnout route or a crossover road, then things get a little bit more complicated. And when you're actually trying to, well, we've actually changed the rules around the way the housings sit, because it was really a change in moving to a higher toe load clip and a more resilient pad. So we're moving more to a pad and clip arrangement that used on plain line sleepers. But there was quite a big assumption, because traditionally on bearers for S&C, the housings were always a set distance from the centre line of the bearer. But what we're doing here is actually, as we rotate around, we're rotating the rail seat. So the whole thing, the pads, the housings, the whole thing's rotating round. Now, like I say, on a straight route, that's quite simple, because the principles are very much like a concrete sleeper. But once you're going around here, you start to rotate everything, and then you start to have problems with the concrete reinforcing bars that go through the bearer. As you start to rotate the housings round, you start to encroach and get closer and closer to the reinforcing bars. So we've had to develop a range of pads which I'll talk a bit more about in a moment, but effectively the stagger between the housings has to change. You can only rotate so far before you have to change the stagger between the housings, then you can only go so much further and you have to rotate it again. So I'll show you some pads in a moment. What else have we done on the bearers? We've also specified standard positions for the insulators for the conductor rail. I think that's all I need to talk about on there. That's right. So a little bit more on concrete bearers. So just the picture on the left, they're not NR56V bearers, they are the old style of shallow depth vertical. They pretty much the same. The other thing I wanted to talk about was standard bearers. The picture on the right there, at the end of S&C, before we run into plain line sleepers, we normally end up with a range of these, which I call standard bearers, 001s, 001Es, and that family. We discovered in doing this NR56V design project that, again, who's got a copy of the 001E drawing? And somebody was ferreting around in a drawer and found something from RMC concrete with a bit of dust on it. So we said we really ought to have this on a network rail drawing. So we have created an REPW drawing, which is 1616, and that shows now the arrangement for the standard bearers, 001, etc. So I spoke a few minutes ago about the offset on the housings. So if you can see here, this is a pad. This is designed to fit around the staggered housings. And you can imagine if you have to then change the stagger, then the pad, effectively, the distance between these two recesses has to change, has to move. So this is the clip and pad arrangement that we've adopted for NR56V. So say it's a higher toe load clip, it's an E plus clip. It's the EP20127, if anybody's interested in the detail. It has a toe insulator here, and it's used in conjunction with a side post insulator, the blue side post insulator. So the cutout in the pad here is designed for the side post insulator to sit into it. So really there's a load of stuff there. I think I've already said all that actually. It was just really a summary, and for anyone looking at the presentation later. The pads, they're all shown on drawings as well. So we've got one drawing that shows all the standard pads, but there are a range of standard pads, and then there's a separate drawing that shows the crossing pads, and the crossing pads are designed to be ordered in kits. So for a particular crossing angle you can order a kit of pads, and they've all been given a pads number for pads, which is always confusing when I get into talking about that. The other thing that we've done is define the pad stiffness, and there are a few people in the room who I've already spoken to this morning who've got a vested interest in pad stiffness. This was a brave step because a lot of our pads previously, although we've got a pad specification, the specification talks about a range of stiffnesses and it doesn't actually specify an actual stiffness. So we took a brave step a few years ago. I think it was me who said in a meeting, we need to specify pad stiffness, and gentleman in the middle there said, very good Ian, tell us what it needs to be. So I won the job of defining a pad stiffness. So looking at lessons we could learn from plain line pads, we took a value. But then of course when you get into S&C pads, the area of all the pads is very different. So you then get into discussions over, do you want a different size, different stiffness of pad for a different size pad? I think we've got the answer to that now, but it certainly led to some interesting discussions. So, rail joints. I said already that we've standardised the joint positions. We have to do this so we can standardise the panel sizes. But again, rail joints, pretty simple really, pretty straightforward until you start trying to get into the detail. But this is what we've ended up doing. So we've got two designs here. One on the, let's start with the one on the right. That's the 4-hole joint, which is relatively straightforward. There's one thing about the clips I didn't mentioned before. So the E20127 clip is only available in a right-handed clip. Now, we've stuck with that. We think the way forwards for maintenance for E is that we don't ask for a left-handed clip to be developed because it's another piece of maintenance equipment that has to be stored, and it's something that people have to have available, and the costs potentially become very high. But again, it was a decision that was taken relatively early on, and it's proved to be a bit of a challenge. But we have a design for 4-hole joints with right-handed clips all round, and we've taken the housings, if you can see, they're moved to the outside of the bearer. So they're moved here, and the housings are actually in line. So unlike the standard stagger arrangement, we've moved them to the outside. So that's not too bad. Then you get to 6-hole joints, 6-hole insulated joints. You can't use an E+ type clip because the toe insulator just won't fit into these recesses. So we've ended up adopting something that's quite different for the 6-hole joint. So on there, two standard clips, E2001 and E1810. There is a left-handed clip there, there's no way of getting around it. Now, these are the same clips that are used in plain line for insulated joints. So although it's slightly non-standard from the S&C point of view, it's a standard industry solution. So you can see here, this is another extract from one of the REPW drawings, just showing what happens with the moving the housings and everything else for the joints. But one of the things we wanted to do with NR56V is enable temporary fish plates to be fitted and holes drilled for backhole fishing. So this is a single hole in each rail. Now there's some advantages of doing this. We've had 1 or 2 isolated incidents where the traditional method of clamping fish plates on, the actual clamps have come loose, and we've ended up with, quite a dangerous situation there. So we wanted to avoid that, but also there's pressure from projects to actually raise the line speed when they hand back. And one of the requirements, if you're going to go down that line, is you need to have a secure joint. So the backhole fishing helps us to do that. So we thought, with this design, why not build this in as part of the standard? So we specify backhole fishing. There's a note down here that talks about backhole fishing. But once you start to do that, and this was one of the things we overlooked on the original designs, was if you're going to have backhole fishing, you actually need to move the housings, because you're going to have a backhole fish joint. You can't get fish plates on, and you can't then clip. So we've had to move housings out there as well. So again, quite a lot of complication. It's only complicated in the design. It becomes complicated if joint positions have to move, because you've then got to decide what you need to do that. But essentially, it's all been included in there. So that was really what I was going to say about layouts, and I was going to talk now about NR56V switches in a bit more detail. So, as I've already said, they're almost identical to the existing design. Now we've kept the E2007 clip. These are the ones that clip onto the slide base plates that are shown in the picture there, purely because it was one other component that already exists as a standard, and we haven't got to change it. We've changed all the blocks to SG iron. So SG iron, spheroidal graphite if you're a metallurgist. It's basically a harder cast material rather than the grey iron that's been used for many, many years. So the main justification is around whole life costs. So the ball and claw is preferred at the switch heel, but there is an option for the stress transfer blocks, and the rails are actually dual drilled, so you can use either. We've also gone for, as I said already, metric bolts. There's standard M27 bolts, and we've fitted anti-vibration nuts. Just a little bit there more about the fastenings, and they're an example of a NR56V stress transfer block and ball and claw arrangement. Now the web washers, these were the things that caught us out. So this is an arrangement for a distance block. So we fitted these web washers on the outside of the joint for a number of reasons. One, because it helps to spread the load from the bolted joint. Another reason, because it actually gives better access to the nut to enable the joint to be torqued up properly. But what we overlooked when we built the pilots was the fact that you can't fit point heating strips. So we have now got a modified design which has been trialled on some of the original layouts, and that's now being incorporated into the standard drawings. Points operating equipment, POE. If we've got a room full of signal engineers, we get hisses and boos. Whichever method of POE we talk about, we get a real passion. Some love it, some hate it. Maybe we get it amongst track engineers as well. But in-bearer clamp lock is the preferred POE system for NR56V, but we have got the holes in the rails for conventional POE types as well. And we're considering, although we're not there, we're considering the introduction of high drive on NR56V. I know this has been requested by some of the routes. And also HPSS. Of course, HPSS has been used on vertical shallow depth in the past. We are planning improvements to the supplementary drive. This is changing the channel rod for a tube to give better load transfer. And what else? Yes, basically just a full review of all the components in the supplementary drive. And we're also working on subtle changes to the lock stretcher bar, basically enabling us to put a bit more metal in it to try and resist the fatigue failures we get occasionally in those. And to the drop lugs at the front for the detectors when you've got a point machine, this is to enable the points heating to be extended towards the tip. Switch toes. Now this is something I always get asked about. Again, this isn't a change for NR56V, but I felt it was, I was actually asked to mention it because not a lot of people know this. And I often get phone calls saying, we've ordered this half set of switches and we think they've sent the wrong one. So this is what I'm talking about here, and it's a switch extension. This was introduced when in-bearer clamp lock was introduced, and for a short time we had, again, two standards of switches. We had switches for in-bearer clamp lock with the extension, and we had traditional switches that effectively finished there. And again, imagine the half set, just like the crossing, turns up on the night, Saturday night, we're going to put it in, somebody's ordered the wrong one. So we set out a few years ago, let's get one standard. Now this is why people think it's the wrong one, because it does actually work with different POE systems, but it doesn't always look like it will. So I've got a picture here that shows an in-bearer clamp lock. Now I was looking for one that showed a conventional setup, and the only picture I found was one that was actually a mock-up I did a few years ago. And I've put a little note on there. It's got the wrong bolts, the bolts aren't long enough, and it's got the wrong nut, so ignore that. But it does show how the lock stretcher and the drop rods actually fit on the rail web, and this cutout in the foot here is designed to enable all of this to fit. So it's a universal switch toe that does both point machines and in-bearer clamp lock. So I couldn't come here today without talking about stretcher bars and about the tubular stretcher bar. In fact, one of my earlier presentations didn't have the tubular stretcher bar in, and so it's, what about the tubular stretcher bar? So I put it in. These pictures are actually from, they're actually production models. They've now gone onto test, and it's planned to be rolled out in projects and renewals, I think beginning in September, between September and the end of the year. So the one I've shown there is a stretcher bar with a red motion unit. These are the standard stretcher bars for shallow depth switches. I think there's a white one for clamp lock, so if you've got clamp lock it might be slightly different. But there we are. So a SIN, a special inspection notice, has been released to mandate the introduction of these, and like I say, coming to you soon. The other thing I was asked to do, we talk about all these different designs of S&C, and some people who use it every day are quite familiar with what it all means, but I was asked to try and do a bit of a comparison about different NR56, NR60. So I've really talked here briefly about I'm comparing NR56V to the NR60. This is the current NR60 design. So talking about the footprint, the fact the footprints are different, although people tell me that if you go down a size you can actually get something that's almost comparable. So a D switch for NR56 is very similar to a C switch for NR60. The obvious things about the different rail section: one's inclined, NR60 is inclined, and NR56V is vertical. NR56V is direct fix. Because we use vertical rails, it's a lot simpler. We can directly fix onto the bearer with a pad. With inclination, you have to apply the inclination by some method. There are other methods, but what we've always done is used base plate to do that. We find that the best method. Talking about PoE there, our NR60 uses high drive. As I've said already, NR56V, currently in-bearer clamp lock or conventional PoE, but we're looking to introduce some of the other systems as we go forwards. And talking there about the switch geometry, secant switch geometry on NR56V, clothoidal switch geometry on NR60. Clothoidal is a lot more of a gentle transfer. And then I was asked to talk about briefly NR56V compared with NR60 Vertical. So NR60 Vertical is still a concept at the moment, but it's something that we're going to be developing. And I think we're going to end up with something that there are a lot more similarities. So we move both to vertical designs. One's a heavier rail section, so one will be effectively the big brother of the other, or big sister. So both will use direct fixed bearers. We'll look at the switch geometry. We'll probably end up with a different switch geometry, and we'll be looking to roll out different ranges of PoE so that we end up with probably a comparable range. So future plans. Again, some of the feedback we've had from the routes. This is a not very clear extract from an REPW drawing, but the point I was trying to make is this is how we divide up the panels. Now, we've got a standard method, standard panel size and everything else, but not all railways are the same. And sometimes if you've got a different Kirov crane, or if you're trying to lift under overhead wires, you can't lift a panel as big. So some people, some projects, some routes prefer the panels to be split up in a slightly different way. So that's something we're going to look at. And again, rather than leaving the routes to come up with their own solution, if they've got different lifting arrangements, we'll come up with an alternative standard. So there'll be two standards, the main standard and then an alternative standard, if that makes sense. But the switch panels will remain the same. It's only the bits in the middle of the crossovers, as I understand it. Talking about S&C base plate. So everything I've talked about already is a direct fix system. Alongside this project, we've been developing a range of base plates. So these again are a range of SG iron base plates, and they're replacements for the existing design of VA, VB, VC, VD type base plates that we use in S&C. So the main reason for doing this is so that we can two level on concrete. At the moment, if we end up having to two level, we go back to timber layout. So we can have concrete bearers either direct fix or base plated. So they're all in SG iron again. And the other thing that we've done is, I might go back a slide in a minute, we've got a system that's compatible with both concrete and timber. So it's the same base plate and it's the same fixing system. And just mention it while I'm here, the same principles are going to be used on new designs of slip switch and switch diamond designs. So they'll follow on from this as well. So yeah, just going back here, this shows the arrangement. So a bit like some of the continental designs, we've got the same screw and we've got a double coil spring washer. So like I say, we can just use the same design and fix it to either concrete or timber. So again, with this will just give us an expanded range of NR56V. So, like everything in life, we've not finished Mark 1, but we're already talking about Mark 2. We thought we'd get the easy stuff, and it's not been that easy, get the easy stuff out of the way first. So there are some of the things we need to do, but these will follow. But switch flexure is key, and this is really looking at analysing how the switch opens, how it bends. So thinking about the toe opening and the flexible length. I've already said before about needing to keep the same footprint, but we're learning an awful lot more now about drive forces, about frictional coefficients of slides and everything else, just understanding what makes the switch work, and there may be some things that we need to do to make the switch operate more effectively. Shallow depth switches, particularly the shorter ones, are very stiff and it takes a high drive force to operate them. So that's something we need to address going forwards. I've already talked about introducing the high drive. We've got some analytical work going on at the moment looking at switch flexure for the high drive, so we'll use that work to study and decide what we do with the non-high drive switches as well. The other thing is the SEN33 check rail. So there are a number of benefits of the SEN33 check rail. It's adjustable and it's easily removed, the two of them. Some of the welds end up behind the check rail because of this modular panel size. So we really need to get to that solution as soon as we can. But it's not straightforward. The example I've shown here shows a check rail base plate for a SEN33 check. But as I've already said, with a direct fix system, then you don't have a base plate, so we've got to develop something special. The other thing that keeps cropping up is the ability to plane line crossings. When we move to direct fix concrete bearer layouts, if you end up with a crossing failure or a defect, you need to take the crossing out. It's very difficult to plane line, and we're seeking a solution to do that. Now, one of the solutions that's been suggested is, well, why don't we just base plate that area, base plate the check rail and base plate the crossing, and you could change the crossing and you can have SEN33 checks. I don't know, it's undecided at the moment, but we've got to think about this going forwards. So the rollout, at last everybody says. So NR56V has been on the burner for some time. We did the drawings, we did the pilots. We got some feedback, some comments. It's taken a while for us to get the drawings updated, but the drawing changes are almost complete now, and we're planning a soft start with the western route, and we've got some layouts identified. Twyford's already been mentioned. I think that's going to be built in the very near future. So yeah, I have to say it here, and it is a thing. Any layouts that people want to do in NR56V, we have to agree that through NDS, and this is really to make sure that all the contractual arrangements are in place and that the manufacturer's ready. There are different tools required, so there are tooling lead times and different components that need to be ordered, so it's important that all of that detail is agreed through NDS. The other thing that we're working on at the moment is some information that says there for the maintainer, but I think actually for the installer as well. The clips we've talked about, the standard clip, E-clip we're using here, E+ clip, does need a different handle puller. So that's one example where we need to provide some information. I've talked about the metric fastenings, it's which torque we need to apply and everything else. Time scales we're talking about, drawings for the A to F switch layouts and the double junctions, they'll be published in the next 2 to 3 months, and they'll go onto the SDC, the Standard Design Catalogue, where the REPW drawings are stored. The SDs I think will follow in about 4 to 6 months, say we've only just commissioned that work. So talking about the way we manage the drawings and the geometry, so I said I was going to use the word standardisation as much, quite a bit today. Promoting the use of standardised designs gives benefits for all of us, and I know there are times when you can't use a standard design, but if you can use a standard design, standard joint position, standard arrangements, please do. And that's really my plea. I got a bit of a cheer, I think, when I said this at a renewals conference in the autumn, that once we've got NR56V in place, we will withdraw, or at least make obsolescent, the 700 and 800 series drawings for the layout, so that there is only one clear way that we're going to do this. And the other thing we've been asked to consider recently are the geometry files. So these are the BRT files, the Bentley Rail Track files. Again, it's who holds this data and who controls this. And there's been a suggestion that when we've got the new range of drawings, that actually we should get that data under some sort of control as well. But say that's very much early days. how we control non-standard geometry is another interesting question. But a number of the manufacturers always tell me, 80% of what we build is non-standard. But it's really understanding what's non-standard. A lot of the geometry, if we're just putting it on a curve, a lot of the bearer information obviously stays the same. You just actually fan the bearers as you go around. So a list there of, or a summary of NR56V drawings. You don't have to remember them all, but there will be a test at the end. And really, that's what it is. It's we've looked at various things. We've looked at really a summary of NR56V, and we've talked about the rollout and we've talked about future plans. So thank you very much for listening.